Hello students, I will discuss today page replacement algorithms. I will discuss three algorithms: FIFO, LRU and optimal page replacement algorithms. So page replacement algorithms are used to replace the page from the main memory to the secondary storage memory, right? So now we will find number of page fault. Actually page fault is an error that are raised by the memory management unit to find the page from the secondary storage memory, and that page should load to the main memory, right? So if the page is not found in the main memory and that page is requested, so there is an error. That error is called page fault. So operating system will find this page fault from the secondary storage memory and load into the main memory. So today I will discuss these three algorithms. The first algorithm is FIFO, first in first out algorithm. So the page is loaded into the main memory according to the first in first out, and replace the page that is load first will replace first, right? So there are page strings are given 1 2 3 4 2 1 5 6. These are the strings that are given, right? Let's start to solve this question. So page number 1 will be loaded into the frame, right? So there are 4 frames in the memory, and these are the pages. 20 pages are requested. Okay, so one page is loaded into the memory, so this page is page fault, right? So this is, I write here F, just a minute, I write here F, clear? So page fault. Then 2 will be loaded into the memory because 2 memory is free right now. Okay, so this is also page fault. 3 will load into the memory, then this is also page fault. Now 4 will load into the memory, 4 3 2 and 1, right? This is also page fault. Now 2 will load into the memory, right? But 2 is already found here, so no page replacement needed, right? So 4 3 2 1. So this page is not page fault, this is a hit page, right? It is called hit page. Now 1 is already there, so no need to change the page. Okay, so this page is also hit page. Now 5. So which page should replace? So which page is the oldest one in this question up to here? So 1 is the oldest one, so 1 will be replaced by 5, right? So 1 is the oldest one, so 1 will be replaced by 5. Another page will be the same, 2 3 4. So this is also page fault, right? Now 6, which page should replace now? 2 is the oldest one, so 2 should be replaced by 6. So 6 5 3 and 4. So this is also page fault. Now 2 3 is the oldest one right now, so 3 will change by 2. So 2, here 4, here 6, here 5. This is also page fault. Now 1. So 4 will replace by 1 because 4 is the oldest page right now. So 1 2 6 and 5. This is also page fault. Now 2 is already there, so there is no page fault in this string. So 1 2 6 and 5, right? Now 3 enter into the system, so which page should replace now? So 5 will replace now because 5 is the oldest one in these all the pages. 1 is nearby replace, 2 is also 6, then 5. So 5 is the oldest one, so 5 will replace by 3. So 3 6 2 1, right? So this is page fault. Clear? 7. Now which page should replace now? So 6 will replace by 7, right? So 7, 3, 2 and 1. This is also page fault. Now 6. So 6, which page should replace now? 2 will replace now, right? So 6, 7, 3 and 1. This is also page fault. Now 3. 3 is already there, so no need to change the page. So 1, 6, 7 and 3. Now 2, so we need to replace the page now. So which page should replace now? Okay, so 1 is the oldest page, so 1 should replace by 2. So 2, 6, 7 and 3. This is also page fault, right? Now 1, which page will replace now? So which page is the oldest one? So 3 is the oldest one, so 3 will replace by 1. So 1, 7, 6 and 2. So this is also page fault. Now 2. So which page will replace? There is no need to replace the page because 2 is already there. So 2, 6, 7, 1, right? Now 3. So we need to replace the page. So which page should replace now? So 7 is the oldest one. See here, 7 is the oldest one. So 7 will replace by 3. Okay, so 3, 6, 2 and 1. See, this is also page fault. Now the next page is 6. So 6 is already there, so no need to change the page to replace the page. Okay, so number of the page fault in this question, how many number of page faults? Number of page faults is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? And number of the hit page, is equal to how many? The black one, 1, 2, 3, 4, 5, 6, right? And the page fault rate is equal to how many pages fault here? 14. So the total page are 20. So 14 divided by 20 and multiply by 100, right? So 70%, right? So 70% is the fault rate. 70%. Clear? So fault rate here 70%, right? So this is the question that we solved today. So this is the FIFO algorithm, first in first out algorithm. I hope you all understand this algorithm, FIFO algorithm. Now I'm going to solve by another algorithm that is called LRU algorithm, least recently used algorithm, right? So according to this algorithm, you will replace the page that is not used for a longest period of the time. Clear? That is not used by the longest period of the time. See, so one will upload to the main memory, so page will be hit. Just a minute. Just a minute. Okay, then 2 will upload to the memory, then 3, then 4, 1, 2, 3, 4. So these are the page fault, okay, because these pages are not found into the memory and these pages are requested page. Okay, now we upload these page into the memory, right? So these are the page fault. Now enter 2 is already there, so no need to change the page to replace the page. Okay, now 1 is already there, so no need to replace the page. 5, now we need to replace the page. Clear? So which page should replace? 1 will be replaced because, no, not 1. See, which page should be replaced? The page that is not used for a longer period of the time will be replaced by 5. Okay, so 1 is recently used, 2 is recently used here, okay, and 4 is recently used, but 3 is the page that is not used for a longer period of the time, right? So 3 will replace by 5. So 3 will replace by 5. Understand this point? So 5 will be here, 4 will be here, 2 and 1. So this is page fault. Now 6. So which page will be replaced by 6? See, 5 is recently used, 1 is recently used, 2 is then used, and 4. 4 is the longest period of the time. 4 is not used by the longest period of the time, so 4 will replace by 6. So 6, 5, 2 and 1. This is page fault. 2 is already there, so there is no page fault in this situation. 2, 1. 1 is already there. 6, 5, 2, 1. 2 is already there. 6, 5, 2 and 1. Now 3. So we need to replace the page. Okay. In this case, 2 is recently used. Okay. 1 is recently used. Then 2 is also recently used. 6, then 5. So 5 is the page that is not used for a longer period of the time, so 5 will replace by 3. Understand? 6, 2 and 1. So this is page fault. Clear? Now 7. So which page should be replaced now? So see here, 3 is recently used, 2 is recently used, then 1 is used, 2 is used, and 6. 6 is the longest period of the time. 6 is not used by the longest period of the time. So 6 will replace by 7. So 7, 3, 2 and 1, right? This is also page fault. Now 6. So which page we need to replace now? So 7 is used recently, 3 is used, then 2, then 1. So 1 is the page that is not used for a longer period of the time. So 1 should be replaced by 6. So 6, 2, 3, 7. So this is also a page fault. Now 3. So 3, 3. Now 3 is there. So we don't need to change a page in this case. Okay. Now 2 is already there. So 7, 3, 2 and 6. Now 1. So we need to replace the page now. So which page should be replaced? 2 is recently used, right? 3, then 6, then 7. So 7 is the page that need to replace by 1. Okay. So 1, 3, 2 and 6. This is page fault, right? 2 is already there. So 1, 3, 2 and 6. Now 3 is already there. 3, 2 and 6. 6 is already there. So now these are the hit page, right? So number of page faults is equal to how many page here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of the page fault is 10. And number of page hit, because total number of the page are 20. So number of the hit page is also 10, right? 10. Now the fault rate, page fault rate is equal to number of the page fault divided by total number of the page and multiply by 100. Okay, so it will be 50%, right? So this is the page fault rate. I hope you understand this algorithm, LRU algorithm. Now I'm going to take the next algorithm. The next algorithm is called optimal page replacement algorithm. So in this algorithm, we will replace the page that will not be used for a longer period of the time. Okay, so understand the point. In LRU, we replace the page that is not used for a longer period of the time, but in optimal page replacement algorithm, we will replace the page that will not be used for a longer period of the time in the future. Okay, so we are talking about in the future. So which page will not be used for a longer period of the time, right? So we will replace that page. Now solve this question. So page, just a minute. So I will take the page number 1, then 2, then 3, then 4, 1, 2, 3, 4, right? Now I have to enter 2. Okay, so 2 is already there. So this is page fault, this is page fault, this is page fault. Okay, so 2 is already there, so we don't need to replace the page. Okay, 1 is already there, so we don't need to replace the page. But 5, so we have to replace the page now. Okay, so 5 is not there, so we need to replace the page. Clear? So see here, we have 1, 2, 3, 4. See, in the future 1 will be used here. Okay, 2 will be used here, and 3 will be used here, and 4 will be used, no any page there. Okay, so 4 will be replaced by 5 because 4 will not be used in this whole process. Okay, so we will replace the page that will not be used for a longer period of the time, right? So 4 will be replaced by 5. Understand? So 5, then 3, 2, and 1. This is page fault. Now 6. So we have to change the page. Now we have 1, 2, 3, and 5. So 1, 2, 3, and 5. 5 is also not there in the whole process. So we will change 5 again. Okay. So 6, 3, 2, and 1. This is also page fault. Now 2. T2 is already there, so 6, 3, 2, 1. 1 is already there, 6, 3, 2, 1. 2 is already there, 6, 3, 2, 1. 3 is already there, so no need to replace the page. Now 7. So we have 4 page, 1, 2, 3, and 6, right? So 6 will be used here, 3 will be used here, 2 will be used here, 1 will be used here. So 1 is the page that will not be used for a longer period of the time. So 1 will replace, 7 will replace by 1, right? So 6, 3, 2, and 7. So this is page fault, right? Now 6 is already there, so no need to change. So 6, 3, 2, and 7. 3 is already there, so 6, 3, 2, and 7. 1. 2. 2 is already there, so 6, 3, 2, and 7. Now 1. So we don't have 1 here, so we need to replace the page now. So which page should replace? So 2 will be used here in the future. Okay, 3 will be used, 6 will be used, but 7 will not be used. So we have to replace 7 by 1, right? So 1, 2, 3, and 6. Now 2 is already there, so 6, 3, 2, 1. 3 is already there, 6, 3, 2, 1. 6 is already there, so 6, 3, 2, and 1, right? So this is page fault. So number of the page fault number of page fault is equal to 1, 2, 3, 4, 5, 6, 7, 8, right? And number of page hit is equal to 12. So page fault rate is equal to 8 divided by 20 and multiply by 100. So 40%, right? So 40% page fault in the optimal page replacement algorithm. So optimal page replacement algorithm has the lowest page fault rate. So this algorithm is the best algorithm in this situation, right? So optimal page replacement is the best algorithm among these three algorithms: FIFO, LRU, and optimal page replacement, right? So I hope you all understand all three algorithms. Okay, so if you have any question, so you can comment on the video, then I will make another video or I will reply to your comment. Okay, thank you for watching.